A mixture of SO2 and O2 at 1 atmosphere in the mole ratio of 2:1 is passed through a catalyst at 1170 degrees centigrade at a rate sufficient for attainment of equilibrium. The existing gas, suddenly chilled and analyzed, is found to contain 87% SO3 by volume. Calculate Kp for the reaction 1 mole of SO2 plus half mole of O2 forming SO3. Now first of all, volume percent is also equal to mole percent. Now initially 2 moles of SO2 and 1 mole of O2 is present. Now according to the balanced equation, 1 mole of SO2 reacts with half mole of O2 to form 1 mole of SO3. So if X moles of SO2 reacts, then X moles of SO2 will react with X by 2 moles of O2 to form X moles of sulfur trioxide. Now total number of moles at equilibrium will be moles of SO2, that is 2 minus X, this is the remaining moles of SO2, plus moles of O2, that is 1 minus X by 2, which is remaining moles of oxygen, plus moles of SO3 formed, which is equal to X moles. And this is equal to 3 minus X by 2. This is the total number of moles. Now mole percent of sulfur trioxide is 87%, which means moles of sulfur trioxide divided by total number of moles into 100 is equal to 87. Solving, value of X is equal to 1.82. Now total pressure, when number of moles was 3 moles, now initially total number of moles was 3. Why? Because 2 moles of SO2 plus 1 mole of O2. So total number of moles was 3 moles. Then the total pressure was 1 atmosphere. Now at equilibrium the number of moles is 3 minus X by 2. Therefore the equilibrium pressure or the total pressure is 3 minus X by 2 divided by 3, and putting the value of X, this is 2.09 divided by 3. So this is the total pressure at equilibrium. Now partial pressure of sulfur dioxide will be equal to moles of sulfur dioxide at equilibrium divided by total number of moles into total pressure, and this is equal to 0.086 into 2.09 divided by 3. Partial pressure of oxygen is moles of oxygen at equilibrium divided by total number of moles into total pressure, and this is equal to 0.0431 into 2.09 divided by 3. Partial pressure of sulfur trioxide is equal to moles of sulfur trioxide at equilibrium divided by total number of moles into total pressure, and this is equal to 0.0871 into 2.09 divided by 3. Now value of Kp is equal to partial pressure of sulfur trioxide divided by the product of partial pressure of sulfur dioxide and partial pressure of oxygen raised to the power half, because in balanced equation the stoichiometric coefficient of oxygen is half. Solving, the value of Kp is equal to 58.47.